which was actually developed by Thales, we could optimize the IMA architecture itself. Martin talked quite clearly on the configuration tool, which is a very important element on this piece of the puzzle. This picture around here, for me, it's not my favorite because actually the flow is not like that. I will present it a bit later, the flow, but really represents you the idea that we want to give to you here is that the ATF provides, I would say, a kind of unified approach to IMA to G in terms of data flow management. And that's very important so we can control the flow and can control what information is going up and many times down because, as you saw from Martin's presentations, and the function modeling, the evaluation and architecture and the configuration itself is not a one-way. Many times from the evaluation goes back to the function to have a better optimization of the overall system. All these with two important constraints, which is industrial constraints. And here we had industrial constraints. Some of the tools were already developed. Some of the tools were being developed. So we had these constraints. Plus what Izep talked about in the morning, we have also the constraint of certification and how we can impact not on the certification of the actual software, but on the certification of the overall aircraft, and also on the qualification of the tools which were already developed. This slide here is to give you an idea what is the current approach to the design methodology. So it's step by step again, but there's not a seamless, I would call it a seamless transfer between the data between the different actors in the supply chain, meaning from modules, from system and model and functional suppliers from one to each other, and also from the different tools. So the process is many times done by email or by direct contact, passing binary files or diagrams. Our approach was really to go through a seamless process where people involved in the process would be all aware of the most updated information, and we'll be all sharing that information with obvious advantage concerning the development time and also the crossing of mistakes or inconsistencies at a later stage. Two notes that I think it's important to mention. When we're talking about the tool framework, we're not considering what I would call the basic software tools like debuggers, like compilers. That's not here. Another very important remark is, as I said, we were dealing with people from different companies with different IPRs over their tools, so with different property rights. So many times it's very tricky to even access the results of that tools, and even more difficult to go into the tools and to have this seamless approach working. So I believe that was really the biggest challenge, and indeed that was placing the risks of the project right down at the beginning. And for you guys that were not here in the first 2 days, even the people that is evaluating the project is quite happy that we were able to go through this approach. You've seen also in this morning this approach concerning how we've interfaced with the different tools, and as I was saying, this for me gives a much better and much more clear view about the data flow in terms of the different tools and different perspective. This was supposed to be more interactive, but it's not working, so I decided to put it on hold. But nonetheless, what it's important to mention here is there was tools with different maturity levels, and for GMV for the overall project people, but for GMV in particular, that was the overall challenge to mitigate the problem of different maturity levels of the different tools. That's one point. And also the other point, which is, okay, we have to take this approach, but how we are going to actually bring value in terms of decreasing the interaction time between the different companies, of the different people involved in the development process. How could we meet the goal of decreasing the time when you identify inconsistencies in the development process? So, and how could this at the end actually produce results which could be loaded into the aircraft systems? The flow itself, as not repeating what Martin told in the morning and now Sintef, which is from the initial models, you can optimize these models at the architectural level. For me, here is, I would say, not hard, but a key element, which is the configuration, which produce actually what we call the configuration tables. And for me in particular, I can tell that I've been working with IMA technology back from 1999, so almost like a dinosaur. And I remember that initial configuration tables were done not even with XML, almost by hand. And building up the configuration tables was a nightmare. So actually the configuration tool is also quite a challenging task for the UH to build it up. It's not one project developing, it's almost two projects, because they're starting all this challenge back in a previous project, which was called Scarlet. But it's very complex because you have many systems, many functions, and above all, a wide network in place inside the aircraft. I don't know, you students, have you seen an aircraft dismantled, but the amount of cables going around is huge. So the configuration tool has to take that in consideration. Also because you have elements or avionic systems in the cockpit, which we call core processing modules, but you also have remote systems, like remote data concentrators along the aircraft. So it's important then that configuration tables take all that in consideration, so things are all consistent. For that, of course, we have also support tools, verification tool, which more focus in Ashkay more on the network, so which we use it's AFTX instead of the ARINC 429 that probably you know from the typical aircrafts that are flying, excluding even the 380 still uses 429, but okay. FTX, which stands for Avionic Full Duplex Switch, so it's like Ethernet on board the aircraft. And simulation tool, which would allow the software people to simulate actually the performance of their software in the core processing modules. How did we build this? And here Cassia was making a very good explanation on day one of this project review. So we had to consider that we had different companies working in different sites, which many times were not able to share all the software inside the tools. So we had to consider that we were going to be working in a distributed environment, and so this is a key element that we had to consider. We had, and since in avionic systems, and I told to some of you guys at the break that many times we are not talking about state-of-the-art technology, but we are talking about technology that actually works and cannot bring mistakes to the flight of an aircraft. So we have to be consistent with what we are transferring. So it was very important to keep track of all the data that is transferred between the different tools. And why is that? I will come back to, I believe, 2-3 slides later on. How we could interact with the different tools in let's say in a seamless, uniform way, and also with minimum impact also at the tools level, because as I mentioned to you, some of the tools were already developed, but some of the tools were being developed, but they were not being developed by GMV, were being developed by other companies or like by TUH, so we had to take that into consideration. This is the next slide to give you an idea about the exchange of information that was going around between the different tools. It looks pretty easy because we're not decoupling the data inside it. This is to show you the bridge between the different tools and how the ATF interacts with them and how the data is archived when data is provided from one tool to the other, and the registry that comes around. And it's going back to the challenge that we had, as I've mentioned, we had two approaches or two mechanisms to solve the problem between the tools that were being developed, which we could actually integrate the ATF, the tool framework, within that tool, and the tools which were already developed, which we were not able, it was more difficult to go to Thales and say, well, please, or to deal and please change your tool because we have a new tool coming in. So we had to take that industrial constraint into consideration. For the first approach, which was what we call library approach, so we were actually able to introduce ATF within these tools. So the people using the tool would see the ATF as a transparent environment. So it was there, for example, as they save the application or they save their modelings, the models will be kept also on the ATF. So people working on another company or using this data could share that data almost in real time. And from a transparent way from the user or from the developer part. On the other end, for the tools which were already developed, which we would almost consider kind of a black box, we had to consider that the ATF would need to do a kind of push, so question these tools which were developed, like the PST, so no, PST is out of my mind what it means, but okay, it will come up later on. To question, do you have new data? Is there new data available that I can share with our repository so others can see it? So to tell the truth, it was not ideal approach, but it's the approach that we had concerning the constraints that we have to live with. Again, and coming back to my prior comment, in aeronautics, we can be with state-of-the-art, but many times we are not the state-of-the-art in terms of technologies, and namely on the GUIs for sure we're not working there. But at the end, the focus was to be efficient and to have this sharing of data between the different tools and this flow of data between the different tools working, and in the way that could not conflict with people actually using the tools. And one important component of all this is actually keeping track of the data exchange, also keeping track of the data being used in terms of even the binary generation. Why? Because this can be actually used, and the purpose and the goal is to even be used by certification authorities. So people could use this as artifacts. So artifacts is documentation that is being produced, so companies can show to them or can demonstrate to the certification authorities like EASA or FAA that things are there, and when we have to demonstrate, we have to bring lots of data to be consistent. And ATF can be one step on that challenge to provide additional data, consistent data to the certification authorities. One additional element that we have here is also, since some of the tools were not available on time while we were producing the ATF, and since we have a constraint of 3 years, which looks like a lot, but in the reality is not much, we had to develop kind of demonstration or fake tools which could simulate some of the tools that were being produced. So our team at CMV were not on hold. We were already working with some API data or ICD data that was provided by the tool providers. So this is just an example about the different interfaces that we had to create to have the tool ready. And right now it's ready and it's being sent to the companies that are using the tool, so they can import and start integrating their environments with our ATF tool. Conclusions. So I'm sure you're going to be very happy with the conclusions. So it means that we can breathe some fresh air. Important. So we build up a distributed architecture, considering the constraints that we have for this activity. I believe the initial feedback that we have from the tool users, so I would say the tool chain people, which will be in this process, is good. We do not have yet, which is very important, and I've pushed a lot, my colleagues Pedro Costa and Cassie in particular, which is please keep and create some KPI so we can actually measure the impact of the tool in the process, because it's important to measure. Do we have actually a decrease on the interaction time between different companies, between the different tools, between the different engineers working on this? Is it possible to have early validation? Is it possible to reinforce the users of the tool because we have actually benefit to the users? Because at the end, as I've started, this is we are talking about money from the shareholder. So if we decrease the cost of the developing of the functions, we can be more competitive. If we can be faster on the development process, we can be also more competitive and bringing benefits at the tier 2 to tier 1, like Thales, from Thales to Airbus. So at the end, it's a win-win-win approach. Last but not least, already thinking about the feedback that we have, how can we in the future even improve further what we are doing?